Hey everybody, I'm Alan Farner and you are about to see my first Trig Nibble. What's a Trig Nibble? It's where I show you something very quickly, and today we're going to talk about how to calculate an arc length. Couple things. First, if you're on YouTube or someplace where you can do that, follow what Davey504, great bassist on YouTube, says, and slap like now, although he does it towards the camera like that. Slap like now. If you can follow, please do subscribe, whatever system that has. And if there's a way to hit an alarm like you do on YouTube, go ahead and hit it so that you can get notice of additional videos. Two other quick things, and I always have to point the opposite direction that it seems on my screen. Math.promo is a site where you're going to get this kind of stuff. And then very important, Indiana University East, Indiana University East, Indiana University Online. If it weren't for them, I wouldn't be able to show you stuff like this. They're teaching me. I'm a student there. And if you're a student there, you made the right decision. It's great to be a fellow student with you. Let's go ahead and talk about this. I'll change my screen here. There we go. So before we get started on how to figure out what the size of a sector is, let's talk about what you're really doing. You all have probably seen a case where you have a circle, and there's this neat thing called pi. See, and I can never tell how much you're going to see the mouse and stuff on the screen, but there's this neat thing called pi, and it's just doing all kinds of funny things. And you may remember from your high school days, or maybe you're in high school right now, your high school days, that pi, that weird number, it's a non-repeating, non-ending decimal. That weird number is if you take the circumference of a circle, this outer part here, and you divide it by the diameter, that gives you pi. And when you're figuring out the length of an arc, all you're doing is figuring out what part of that circumference it is. And if you think about it, you've got pi equals the circumference times the diameter. Right, got that there. Therefore, and I love the therefore, makes you feel real like you're a math person. Therefore, your circumference is equal to pi times your diameter. Radius, which is this subpart here, right? Radius is your circumference over 2, which means that your circumference, what am I saying, diameter, your diameter over 2, did somebody pick that up already? Is diameter over 2, which means that if you want to figure out your circumference, you now have to go 2 pi r, because r is half of the circumference. If you look at this, your 2 and your r is how you're going to get that. So 2 pi r. Now, measuring in radians, and you might prefer degrees. I used to prefer them in high school. I actually like radians more now. But in radians, if you go around a circle, all the way around a circle, it's 2 pi. Okay? If you go all the way around a circle, it's 2 pi. So based on that, if you look at that, notice the 2 pi here and the 2 pi there. Keep those in common and think about it. If you've got 2 pi radians, then you've got a whole circle, which means you have the whole circumference. So if theta, we're going to call your angle theta, if theta is 2 pi, then it's your whole circumference. You're going to have the whole circumference here again. If theta is less than 2 pi, it's a part, it's an arc on your circle. It's some portion, right? Some portion on your circle. And if it's greater than 2 pi, I know I put here, it said an arc is a portion of the circumference. Well, if you go more than 2 pi around, you're going to have an arc that is greater than the circumference of the circle. So, how long have we been going? I don't think I have a timer on this thing. How long have we been going? Trying to keep this short. What if you want to figure out, you can see my original angle. I wonder if I can erase this safely. See if I can get rid of that. Let's get rid of that. Let's get rid of that. If I have an original angle right here, call that theta, and I have my radius, how do I figure out this? We'll call the arc S. Well, to figure out the arc, you take S equals the radius, and remember we have the radius over here, times theta. And remember, if theta equals 2 pi, then it's the entire circumference. If theta is less than 2 pi, it is a smaller than circumference arc. And I'm not saying you'll never get a theta that's greater than 2 pi, but my guess is most times you're given a math problem, theta is going to be less than 2 pi. Your angle is going to be less than 2 pi. So it's really simple, actually. So let's just, for argument's sake, we'll make one here. Let's say our radius here is, we'll go radius equals 5. And often you're going to see when you have radians and you're doing stuff like this, they'll say theta is something like pi over 3, which, by the way, is 60 degrees, okay? Because if 2 pi equals 360 degrees, pi equals 180 degrees, and then pi over 3 would be 180 degrees, 60 degrees. Simple enough. But we don't want this in our calculation. We won't get the right answer. We want this. So based on what we said here, S, if radius is 5 and theta is pi over 3, S is going to be 5 times pi over 3. And let's fire up the handy dandy TI Inspire CX2. And we're going to go ahead, and by the way, in your calculator, just make sure you're using the right type of degree angle measurement, degrees or radians. Otherwise, you'll get some interesting answers. Part of the reason I like the TI Inspire CX and CX2 is you can actually you can keep, like I keep it in radians, but if I get something in degrees or degrees minutes seconds, I can go ahead and force it to know that I'm entering those instead of the radians. But I'm going to go 5 times, let me bring up pi, divided by 3, and it's approximately, and there's your approximate symbol, go 2 decimal places, 5.23. So now let's think, does that seem reasonable? Well, we said if we wanted to get the entire circumference, it's 2 pi times radius. So what's our total circumference? Our circumference is 2 pi, which is the equivalent of 360 degrees, or a full loop around the circle, times 5. So now if I go 2 pi times 5, I get 31, approximately 31.41. And if you think about it, remember this is pi, not 2 pi, pi over 3. So that's like dividing this by 6. So if I take 31.41 and divide it by 6, by the number 6, yeah, you'd expect something in that ballpark, wouldn't you? So there you go. Now, if you're going to show your work, you're going to do it nicer than this. We'll have other videos on how to show work, or at least one other video on how to show work. If you have any questions, feel free to email me at Alan at, let's see, which one we'll use, math.promo. And as long as I'm going to school, I'm A. Farner. Boy, my handwriting is getting bad at the bottom of this, at IU, IndianaUniversity.edu. Love to hear from you. Send me a note if you have anything you'd like me to do a video for, especially some kind of nibble. I'll have other like pre-calc nibbles and algebra nibbles, but trig nibbles, just hit me up. We'll see you later. Now I got to figure out how to turn this thing off.